All right, welcome to the CTO Advisor, the road to DevOps. I advertise this as the steps you take before you even consider buying a DevOps product. There are tons of products on the market that advertise themselves as I want to say most marketers are fairly honest when it comes to marketing, but they label themselves DevOps tools. And I think it's important to understand the DevOps processes and prereqs before you even go out and buy a tool. DevOps is definitely not something that you can buy a tool, implement it, and then you're good. It's not like VMware vSphere where you say, okay, I want to virtualize my environment. So I'll go out and buy VMware vSphere, I'll go out and buy Hyper-V, or I'll go out and deploy KVM and follow a roadmap to virtualization. Straightforward. Can't do that with DevOps. I can't go out and buy Ansible and now I'm a DevOps environment. Very different use cases. So with that said, let's talk about the business value DevOps brings an organization. Basically, why do I even bother with DevOps? I think the number one thing that it brings a business is business agility. The ability to take, there's this concept code to cash, similar, idea to code to production. How can I reduce the amount of friction between the business and IT so that IT becomes a partner to the business versus just a cost center or a nuance to be managed? Second, it reduces risk. So one of the aspects of DevOps is that as you implement DevOps practices such as automated code review, you want add agility and you speed the process to get the code into production, but you also automate the checklist associated with implementing that code. So you take out some of the human factor in errors for code, server builds, network changes. No matter what you're DevOpping, I'm going to pen that as a verb, DevOpping, that you have this ability to reduce downtime associated with human error. And as a result, you're going to get less support calls. That's both, that's both a cost reduction and a reduction of risk. And then there's the reduced cost. This is, I think, a major driver for many organizations. When we first looked at the term DevOps, we thought cloud native. And if I'm not in a cloud native environment, why should I care about DevOps? And then we started seeing tools like Ansible, network vendors talking about programmatic networks and APIs to network and intent-based networking. Right now, Network Field Day 17 is going on, and Cisco is talking about all of these DevOps-like concepts and what looks like legacy IT. So we have the ability to implement DevOps automation to reduce overall labor costs associated with things that we traditionally threw people at. We would, if you were deploying a new data center, you need to deploy, 30 top of rack switches. You deploy an engineer to configure the CLI, the command line interface for each one of those switches. So that might be 2 weeks of man hours of someone just factory deploying switches versus racking and stacking those, pushing a button, and automating the deployment of that. It reduces the cost associated with provisioning traditional services. And we'll talk about how that impacts the development process in the next slide or two. And then it allows you to use commodity services. You find as you start to automate and DevOps and move to a DevOps operations that a lot of the fancy services that we bought within, like, let's say a server vendor, you might be used to what used to be called Compact Insight and moved into HP Insight, or now HPE Insight or Dell Open Manage. These products that were designed specifically to manage hardware implementations from a particular vendor. You couldn't use Open Manage traditionally to manage your compact HPE infrastructure, but now you can take things like Puppet, Chef, and apply these DevOps principles across hardware vendors. And you've abstracted away that. Now you've gotten to the point, you've abstracted away that management, and now you've gotten to the point where you can even use white boxes for some of the capability you will have looked to Dell or HPE or Lenovo to do because of their proprietary management solutions. The same across, this is not just a hardware thing. This is across cloud services as well. We have, solutions like AppFormix and cloud templates and cloud forms, and the list goes on and on to normalize cloud services or the management of cloud services across multiple clouds, whether it's a private cloud or a public cloud. Netflix talked about this an awful lot in their white paper on Titus, their orchestration tool for managing containers, about the need to normalize services across their private and public cloud. So DevOps does three things: provides business agility, reduces risk, and reduces cost. I think those are the primary business drivers for pursuing a DevOps infrastructure or operations. So which model of DevOps are you interested in? I think that's an important question before you go down the DevOps journey. You may ask yourself, Keith, I didn't know there was more than one DevOps. I get this question. Well, actually, I ask this question anytime I'm engaged to advise an organization on DevOps. I'll get a call from an executive that says, hey, Keith, I need help with my DevOps. And the first question I ask is, what kind of DevOps are you looking for? I had a picture originally that had on the left-hand side where it has application-centric, a picture of Netflix, and then on the right-hand side, infrastructure-centric, a picture of VMware and VMware VOps. They are fundamentally two different value propositions. The application centric, which are what I like to call, mode one DevOps, actual DevOps, is when I'm integrating the operations of my infrastructure within the application. Again, Netflix is the best model to kind of hold up and show as an example of this mode one DevOps. This is where applications are actively monitoring the infrastructure. Scale and elasticity is built into the application. The data center control plane is part of the application. So if there's a failure in the infrastructure, the application itself is self-healing. It'll alert an operator if needed. If the issue can be resolved by deploying more workers or more workloads, the application calls to the infrastructure to make that happen. The overall health of the application is monitored via the application. Developers, and whether they're front-end developers and back-end developers, are working together to ensure that the application itself manages the infrastructure or operates the infrastructure. Though where I believe the term DevOps originates from, what I call pure DevOps. This is the idea of getting rid of your, quote unquote, getting rid of your operations team and collapsing your development team and operations team into a single team, and the application itself controls the infrastructure. So obviously there's a lot of value in that. From our previous slide, we saw all the things that we love to do that. If you're building an application from scratch, this makes sense to pursue this pure DevOps model. However, if you're in a brownfield and you have traditional workloads running in virtual machines, bare metal servers, etc., and you simply want to reduce the cost and risk associated and add agility associated with managing that infrastructure, there's a lot of advantages that come from DevOps. If I can automate the deployment of a VM, then I can reduce the time that a business waits to say, oh, well, you know what, I want a new Oracle database and deploy, a new CRM tool on top of that. If you reduce the wait time from a month to a day or 2 days, then that adds tremendous business value from a agility standpoint. If you can automate the deployment of a virtual machine so that it's not a form of art every time a engineer builds a server, then you reduce the cost associated with deploying a server from a risk and support perspective. Same thing with our ability to reduce cost. Less time I have server engineers building servers, more money I save. So again, both models of DevOps absolutely are valid approaches, but you need to understand which model of DevOps you're going to pursue because they're very different operationally, which brings us back to the point of all of this, that DevOps is, again, like any other technology or governance model. It's about people, process, and technology. You can't ignore the people and process part of this discussion. And I think this discussion, this webinar is based on the concept of examining people and process before you even look towards the technology. You need to ask yourself some basic questions when you're looking for a DevOps model. One, from a people process, who will be impacted? Now, the obvious part is, of course, IT and developers will be impacted when it comes to DevOps. But that's not it. Remember, we're trying to add business value to business users, so the business will get impacted. So let's expand out from just IT and look towards, let's pick a group randomly, accounting. People account for IT infrastructures in 100 different ways. When you deploy a VM, the VM might need approval from the finance team, the application team consuming the VM, security, compliance, etc. If you automate the process to deploy VMs within your IT organization and it breaks your back-end accounting, that's a bad thing. So you have to get these external groups. You have to examine. We'll actually walk through a process. You have to look through the process and understand when you automate or quote unquote DevOps a process, who's impacted in that chain of automation. Again, and that leads to how will they be impacted? Do they need to change their own systems? Do they need to go to the next point, more training? Outside of IT, do I have to train my business user on how to consume my DevOps environment? If I'm providing an API to my data center, I have to implement and I have to implement an API. Therefore, do I need to send my business user to OpenStack training, to I deploy this whole thing in AWS? Do I need to send them to AWS training? Do I need to have an in-house set of training materials on how to consume the infrastructure that I build now that I've automated it. Then process. You can't automate what doesn't exist. This is probably my most popular tweet ever, 110 retweets. You can't automate a process that doesn't exist. A lot of enterprise IT, the reason why we have challenges with support, risk associated with downtime, is that a lot of enterprise IT, for all the science behind the technology, is very artisanal. Two engineers deploying the exact same solution will deploy it in two very different ways. So we gave the virtual machine as an example. You can have a template in VMware that says deploy virtual machine. There will be some steps to configure the virtual machine post deployment. One engineer may have a very good relationship with the person that manages IP addresses within your organization. The other person may not even be on speaking terms with that person. So one person can deploy a server, get an IP address within a couple of hours and have the server deployed in one day, where another person would have to get in the queue and wait to deploy a virtual machine because they're waiting on the IP address. That's just the nature of people, processes, and technology. When we marry those things together and we say we're going to automate it, if I can't write down the step-by-step process on how I do something, this is computer science 101, garbage in, garbage out. If I can't write the process down, then I can't tell a computer to do it for me. So we can't automate a process that doesn't exist. We're going to spend quite a bit of time going through a CI/CD process and seeing where some of the holes are when we talk about DevOps. Which, to reinforce that point, there's no AI for DevOps. I can't go to my DevOps tool and say, oh, I want to implement a CI/CD development pipeline process based on what we've done in the past, and my tool magically figures out everything that needs to be done in order to automate that process. AI for DevOps does not exist. So before we get into the CI/CD process, I'll pause for questions. If there's no questions, we'll continue on. So a brief 15-second pause for those of you on YouTube watching this. All right. With no questions, we'll go ahead and go on to the continuous integration map that I've downloaded from SlideShare. A tip of the cap to EPAM systems for what I thought was a pretty good process that I didn't have to reinvent. So we'll start at step one, CI/CD. I've literally gotten this question from a Fortune 500, which was, we implemented a virtual environment for our developers to create code. And they love the environment. However, we run into all kind of problems with trying to deploy to production because now we have this distributed model for code development, but we don't have any controls in place to get that to production. Keith, help me fix our DevOps. Well, you know what? To be honest, you don't have DevOps. You have a bunch of tooling. And I'm sure the developers love the tools, but there are no processes to automate in order to, say that you now have DevOps. And I thought I'd use this development lifecycle just to call out some of the pitfalls that many companies fall into when they look to automate or adopt a DevOps-like principles in managing their infrastructure and their applications. So step one, development team. You know what? I have source code. I want to create source code. We create environments for developers to create source code. The source code is created, pushed to a version control system. So that's step 1 and 2. Obviously, most people have step 1. They have developers creating code. most organizations, hopefully at this point, have some type of version control system. Whether you're coming from a DevOps environment to a non-DevOps environment, there is version control that gets complicated as you get more and more teams and more development environments. So you might need to look at a new system like Git, but for the most part, version control systems are there. Then you go to source code build. And this is where we start to see some of the first cracks in the system. If you have separate development teams creating separate sets of code, and we no longer have this concept of a build day, so you have to have your revisions in by a certain point in time, a developer can, on their container focused development environment on their laptop, can build versions of their code at any point in the day, let alone the week, then that complicates the remaining sets of steps. This is something that has to be given some thought. If I'm going to distribute the load across several developers and give them independent ability to code and build and submit source code, and I no longer have a single day to say, okay, code revisions have to be in it by this point in time so that we can build and now have this process of how I analyze the code. And again, people normally fall down at this point because they said, oh, I've given independent tools, I have DevOps. No. How did these changes impact your down the line processes? Static code analysis. These are things that people used to do by hand. You may now automate these things, and you can automate them. But if you don't have a checklist of how do you perform code analysis, let's say you want to automate code analysis. If you don't have a checklist of the things you check for in code analysis, you can't automate it. Can't automate what you haven't written down. Run automated unit tests. Again, this is something in the past that we've done manually. When we had one big code build day, we could do integration testing. If you've distributed the workload across several developers and given them independent schedules on being able to build and test review code, now the test of that code has to be automated in a fashion that we have a CI/CD process that I can update my production application several times a day. Well, you need to be able to automate the text functions within that process. If someone has to manually review the code and do manual integration testing, then it's very difficult to do CI/CD. And to the point that if you haven't written it down, if test is not something, if the test process, the things that I test for in my integration process or in my development process, if I can't script that, I can't deploy it to Ansible. If I can't deploy it to Ansible, Ansible can't automatically approve the changes that I'm going to make in production. Code coverage analysis. Not really sure what they mean by this in this example, but we'll fast forward. I think we're getting the point, I think. If you can't get down to the basic principles in detail of all the processes needed to get code from a coder's desk into production, then you cannot DevOps. You need to first start with this process, develop a process for how you get code to production, document the steps in which it takes to do that, the details within that steps. Once you can script that, you can automate it. Once you can automate it, now you can go into a mode of DevOps. So that's it. Just overall principle. You can't automate what you haven't written down. You can't automate a process that doesn't exist. If you can't do that, your DevOps projects won't get the business value or benefits you're looking to get. You won't add agility. You can't add agility if the processes are broken. You won't reduce risk. You can't reduce risk if the processes are broken. And you can't reduce cost if you can't automate and limit the number of people that have to touch code, that have to touch systems to review and ensure that they meet the requirements of the business.